Men, and I use the term ever so loosely. This is the follow-up video to last week's video where I made the test apparatus for checking some of these wires out. But to the point, does any of the wiring on your bike look like this? If it does, you probably need to redo it. So let's take a look at some of these things and see what's going on here exactly. I cut this harness out of a bike I installed an engine in a while back, and I kept it as an example of shitty wiring. Usually you don't have to look too long or too far to find examples of shitty wiring. Here's a piece of wire. The insulation is so brittle that it actually cracks. Got an illegitimate crimp on it. This is no fucking good. You know, you don't want your wiring to have crimps that look like this. Butt splices that are no good. We're going to do a little testing on some of these, so I'm going to cut them out of the harness for further abuse. We'll test that one. Here's one. No fastener whatsoever, just twist it together. Well, okay, it's the middle of the night. What are you going to do? Let's see, we got some more wiring. So brittle that it cracks. Probably routed too close to an exhaust pipe. Oh, here's one of my favorites. The bad solder job. You know what, let's get this all out of here. Alright, here we are. It's all entangled. Let's look at this. I can't think of any reason why you would need to do this on a motorcycle wiring harness. Look at this soldering job. Jesus Christ. But anyway, it was driving around. It ran, I guess. Some more shitty crimps. We'll probably test this one. Maybe we'll test both ends. What else do we got? Ay. Just crappy connections. This actually is a fairly higher quality connector. Here's one. This is a good one. I don't know if you can see this little loop over here, but the crimp is too big for the wire, so the guy doubled the wire up and shoved it in there and then crimped it. That's probably not actually too bad of a thing to do. Here's one. The barrel's all jacked up. It only crimped on one side of the barrel. The other side is just kind of flopping in the breeze. Ay. More junk. This looks like it was crimped with a pair of pliers. What do we got over here? Here's another bad crimp job. The barrel on the terminal split and part of it's just kind of hanging out there. The fuck is going on over here? Let's cut this off and see what's under there. See if I can do this without injuring myself. Hard as a rock. Alright, we got some repairs. Covered with a piece of clear tube. Covered with a piece of tape. The actual repairs covered under heat shrink. Let's see what he did under the heat shrink. another crappy solder job. Jesus. Got a little green corrosion forming in there. Nothing too surprising. And garbage. Here's one for you. What's going on over here? Oh, this is interesting. He's got this cloth tape, and it is the stickiest shit I have ever seen. And look at this. We got a crimp that's, I don't know, 3 or 4 or 5 times bigger than it needs to be. I don't know if you can make out how distorted that is in there, but just junk. And then, of course, you know, a ½ an inch from the terminal, you got a butt splice, a crappy butt splice. Just garbage. Anyway, you guys get the idea. This stuff is all junk. So you may ask, if all of this is no good, what is the better way to install wiring? And having formerly worked on airplanes, I'm going to be using this as a guide. The venerable EA 4313-1A version 3, Acceptable Methods, Techniques, and Practices. My favorite aircraft book. And it talks about wiring. A lot of guys are prone to soldering. And in some applications, soldering works good. However, the book lists disadvantages. Corrosive flux may cause the joint to deteriorate. Maintenance is extremely difficult. That would be peeling off the protective coating, the heat shrink or whatever, dragging a soldering iron out to the airplane or the machine and soldering. This is particularly important, I think it says. Wiring strands are stiffened by the solder and become more susceptible to breakage due to vibration. And indeed, the solder joint makes the wire very stiff, and it is not flexible. You know, here's one here. The solder is very hard to bend, but where the solder ends, you know, this is going on the whole time you're riding, and as you see, it's going to break off fairly easily. So not usually a good option, although in some cases it's necessary. And the wire insulation may be damaged during the soldering process. We've all seen the wire insulation melt when you put a soldering iron to it. Since the early Middle Ages of wiring there, I guess, the crimp-on terminal has replaced solder in most cases. And the book talks about it. Copper terminal lugs. That's what all of these little doodads are. They're copper usually. Solderless crimp-style copper wire terminal lugs shall be used. And by shall they mean must. Terminal lugs shall conform, and by shall they mean must, conform to MIL T 7928. This is available on the internet. Anybody could look it up. But it talks about the way the crimps are formed, the thickness, the material, the plating, the vibration resistance, the tensile strength. Anything you want to know is going to be in this MIL T 7928. Chief among those things, you will find a chart that looks something like this. And I'm going to be talking about 16 gauge wire because most of the wiring on a bike is 16 gauge. 16 gauge wire right here. Minimum tensile strength 50 pounds. So I should be able to pull 50 pounds on a 16 gauge wire and it won't break. The crimps for 16 gauge wire, 183 newtons, that's that metric shit I don't care about, shall break at 41 pounds, no less than 41 pounds minimum. So we're going to do some testing. We're going to test some of these. We're going to test some new ones. We're going to test a couple of different crimpers, and we're going to see what happens. Crimper tools. These have been known to be used as crimper tools. Piece of wire, it'll work. A lot of guys use these. Some guys use these. Most commonly used, however, is probably something like this. This is what I use. These are aircraft style crimpers made by the Amp Corporation. I think Amp was either bought out or merged with a company named Tyco. These are designed for the aircraft style crimps that I use. And they ratchet, and the purpose of the ratcheting is to make sure that you can't release the crimp from the dies here until it has been fully compressed. So once you start, you're committed. You can't let go of this thing. You have to complete the crimp to get it out of there. The die part of it has two stages. One part is for crimping the wire, and one part is for crimping the insulation on the wire. It's got a little guide over here to make sure that the crimp is inserted to the proper depth and aligned with the insulating part of the crimper and the wire part of the crimper. It's got one adjustment on it, this guy over here. You could change the tension on it to some degree to allow for sticking two wires into a crimp into those situations where two wires will fit. This is, well, I think a new one of these is probably several $100s. I bought these used, 40 years ago maybe, a long time ago, and they have crimped thousands and thousands of wires, I'm sure, in their day. But anyway, the state of the art, although most guys use this, auto parts store, 12 bucks or whatever, probably Amazon these days, $5, $6. Anyway, those are different kinds of crimpers. Let's look at some crimps and I'll explain why it matters. I'll do my best to explain this. This is your standard automotive store type crimper. It consists of a flat piece of metal with a hole stamped in it for the terminal that it's going to go over, for the stud it's going to go over. The flat piece of metal is formed into a barrel, and therefore there is a seam in the barrel right in the middle of the top of this thing. And that seam is what's split over here, and you probably can't really make this out too well on the video, but that's this tab that's folded up over here. It's where the barrel split. One part of the one side of the the formed roll piece of metal didn't crimp and it's sticking up in the air. The other part is flattened over. When your barrel is not continuous all the way around, this is the kind of thing that could happen, and of course it reduces the crimping pressure on the wire. Anyway, standard hardware store, auto parts store crimp. So the flat piece of metal is rolled into a barrel. The barrel has a sleeve. And the sleeve is covered with a piece of insulation, this plastic, which is continuous all the way around. So here we have the barrel and the piece of plastic over it, okay? Standard auto store stuff. Down below here is the aircraft grade crimp. And you look at it and you say, well, hell, it's not any difference. In fact, it is different. The terminal lug starts out as a flat piece of metal. It is formed and rolled into a barrel, except for where the edges of the barrel come together. It is brazed, soldered, welded. I don't know how they do it exactly. This is copper and it's tin plated. I'm not sure what the joining process is, but per the mill spec, the barrel must be continuous. So when this thing is done, there is no seam. You could see where the seam was, and you could also see that it's been joined somehow or another. On this one, when you look from the end, you'll see that the seam is clearly visible and it is not joined. Anyway, that's this part of the terminal. Outside of the barrel is another formed ring of copper that goes around the whole thing. When the dies come down, it crimps it in through here. The die is a two-part die. The second part of the die crimps this outer barrel. The outer barrel is designed to crimp over the insulation to support the insulation and therefore the wire when it goes through the crimp, trying to reduce the amount of flexure where the crimp meets the wire. And then, of course, on the outside is the plastic insulating barrel that goes over the whole thing. The mil spec actually speaks as to how much this plastic can be moved off of the metal barrel, and the answer is practically none. Whereas on this kind of a crimp, I could probably pull that off of there without a great deal of effort. You know, does it matter? I don't know. On an airplane it matters. On your motorcycle at 3 o'clock in the morning heading home from a saloon, yeah, it probably matters. So this is far superior. It also costs a bunch more. You know, these are in the neighborhood of pennies a piece. These guys are 20 to 80 or 90 cents or a buck a piece. These are very pricey. I don't like to waste them. But anyway, the much better way to do it. Although I'm sure these terminals are probably available from a lot of places, I get them from a company called Mouser Electronics. And this is a page, Mouser, out of the Mouser catalog. And they have a warehouse in the Dallas-Fort Worth area. And for me, this stuff is just about overnight. But anyway, the kinds of terminals that are available, a list of the part numbers and what sizes they are for the wire gauges, etc., etc. Kind of a quickie reference on these things. You find them on eBay. You could find them on Amazon. You could order them from Mouser. But anyway, this is where I get my stuff at. And here is the tool. This tool. This is the new improved version. Their little picture here is the new improved version of this. Functionally the same and identical, and I'm sure this is probably over 300 bucks. You know, you're some guy working on your motorcycle. Do you need this? Probably not. You probably could live with this, I guess, but for the most reliable applications, I use this. And if you're working in a shop and you're crimping, you know, hundreds of terminals a month or whatever, or you're, you know, doing production work on a guy's bike where you don't want a bad crimp to have the job back on top of you, you should be using something like this. And just FYI, here is the actual chart out of the mil spec to which these terminals are manufactured. And this is a 40-page document, and you can see this is, I mean, look at the typeface on this thing. This was probably typed out on a typewriter and scanned into the computer system. This was long before the computer age. But anyway, you know, just so you know, I'm not speaking out of my ass. But you know, y'all can look that up. The whole mil spec is available on the internet, and that is Mil T7928. Mil T7928, if you're so interested. So we're going to meander over to the newly modified hydraulic press and use it to stretch and break wires. We're going to start with some of these shitty old harness I pulled off of that guy's bike, just to kind of see what goes on. And then we're going to crimp some of my expensive crimps onto pieces of wire and see how long it takes them to break. And we'll do some of the generic automobile type crimps and see how they hold up. And we'll just see. We'll see how it all works out. Alright, I got the first test sample strung up in there. It's kind of crimped, it's kind of soldered, it's a little bit of both. Let's see how it holds up. Alright, we're at 26 pounds. Alright, the wire broke before I let loose. So as crappy as that connection looks, that was pretty strong. Strong enough anyway. Okay, hold this set, it's zeroed out. Just a plain, crappy auto parts store crimp with, you know, this is one of the ones where the barrel wasn't formed correctly when it crimped. Let's see what it does. Well, feel the wire breaking. "27 pounds, the wire broke." Well, you know, I'm going to blame that on these pliers. I think I creased the wire and caused it to break down here. Okay, on that last one, yeah, the jaws of the vice grip creased the wire when it broke where the vice grips had a hold of it. So I just tied a knot on this one. So let's see what happens this time. Okay, pulled out at 19 pounds. Wire stayed intact, pulled out of the crimp at 19 pounds. That was kind of what I expected. Okay, we're going to go for this thing with the double wire crimped in it. I think this is going to pull out a pretty low pressure. I'm going to have to use the vice grips on it because there's just not enough wire to tie a knot. I'll back the pressure off a little bit and see what happens. Alright, let's see. Let me zero that again. "72 pounds. One wire. It's interesting. Okay. Well, maybe not simultaneously, but one wire pulled out of the crimp or broke right where it came out, and the other one pulled out of the splice. But still, 72 pounds, that's respectable. Okay, got just another plain old automotive type crimp on end there. Let's see what happens. $34. Okay, the wire didn't pull out, it broke right where it comes out. Okay, this one here, I was in the process of tying it onto the rod I got going across over here, so I was just tugging on it and it popped out of the crimp, so we'll call that one 1. Okay, got another plain old automotive type out of my junk harness. This particular one looks fairly well executed. Let's see what happens. That's still pretty good. You know, frankly, on a lot of these, I thought the ring was going to just pull out and break. I'm impressed. And there we go. The wire pulled cleanly out of the crimp at 57 pounds. That's not bad. That's pretty good performance. Alright, back to the vice grips. There wasn't enough wire there to tie it on. Let's see how this one does. This is a fairly well executed crimp out of that junk harness I had. It's the last one, and we're going to switch over to some new crimps. $27 pounds. The wire pulled cleanly out of the crimp. Yeah, pulled cleanly out of the crimp. Anyway, so much for the junk harness examples. This was in a bike that was driving around most of the time, I guess. Let's switch over to some new crimps and some new wire and see how they do. Alright, for the first round of actual tests, you got your generic auto parts store ring terminals, and this is one of the mil-spec aircraft ones. I'm going to crimp these, one of these, and one of these with the automotive grade typical crimpers, and then I'm going to crimp another one with the mil-spec aircraft grade crimpers, And then we have a mil-spec crimp that I'm going to crimp with these, and we'll see what they break at. I have a brand new 16 gauge wire, and wire's expensive these days. I really hate wasting it. One of the things I'm going to be real careful of is not to nick any strands when I strip them. This is 16 gauge wire, so I'm going to use the 14 gauge hole on these strippers to avoid contact with the wire. The color codes are for different size. The blue ones are supposed to be 16 through 14, I think, and the red ones are supposed to be 18 to 22. I find though that the 16 gauge wire fits in the red splices even though it's not supposed to. So let's crimp this one with the automotive type crimp. Okay, that's good. And then let's take the other one, the other red one, and we'll crimp it with the aircraft style crimp. And you'll notice the aircraft style crimp put a crimp on the plastic part of the insulation to help strain relieve the wire where it goes in and out of the metal part of the crimp. I guess I could do the same thing over here. I don't think this is going to do anything because on the aircraft style terminal, this guy here, there is a thin metal part of the barrel that extends over to here, so the wire is actually supported by a piece of metal. And I picked these two red ones and these two blue ones because although they're both the common AutoStore variety, they're a little different. They're different manufacturers. In case y'all missed the last video, this is the rig we're going to be using to do the testing in tonight. It's old Harbor Freight hydraulic press. I've welded the uprights to the legs so that it doesn't rack back and forth anymore. I've rigged it up with a cable and a pulley that I could put my scale on and stretch wires in them to see when they'll break. So anyway, this is the rig made in the last video in case you missed it. Alright, I got a standard automotive type crimper, crimp in here, crimped with the automotive type crimping tool. Let's see when it breaks or pulls out. Okay, wire pulled cleanly out of the crimp at 31 pounds. Okay, this is the automotive type crimp with the aircraft type crimping tool. Let's see if it makes a difference. It's making a difference. Alright, what do we got? 62 pounds and the wire pulled cleanly out of the crimp. I think that's the best result so far. Alright, now I got a standard automotive type red one, crimped with the automotive type crimpers. £53. That's impressive. Alright, we got a standard blue automotive type crimp, crimped with the aircraft type crimping tool. Let go at 46. Disappointingly low. Okay, last in this batch at least, we have the aircraft grade ring terminal crimped on with the aircraft grade crimper. I expect this to break or pull out in excess of 70 pounds. Let's see what happens. Something just yielded. Ooh, rather disappointing. 57.8. Interesting. And just for fun, we're going to try this one. Hey, it's late at night and you're stranded by the side of the road. What are you going to do, right? Not the prettiest thing in the world. But, hey, it's on there. Let's see what happens. Okay, here is the smash with the rock. I actually think this is going to do pretty good. Felt something yield. That's it, it's pulling out right now. 40 pounds, pretty respectable for a smash with the rock. I'll take it. Okay, I got a red aircraft grade crimp ring terminal crimped on with the aircraft grade crimper. I had previously done a blue one crimped with the aircraft grade crimper and an aircraft grade ring terminal, and it let loose at a surprisingly low amount of force, but this is a smaller diameter crimp barrel. So I'm going to run this test again and see if we get a better result. $59.2. Yeah, that's what I was expecting. And this is what I was really expecting. The wire broke before it pulled out of the terminal. And that's what you should be seeing. And I don't know if you could pick this up on the camera right now. Notice how it stretched the eyeball here. But this is what I expect. On the aircraft grade crimpers and the aircraft grade terminals, I expect the wire to break before it pulls out of the ring terminal. And that's what we got this time. Clearly the best result. I mean, it's stronger than a wire, and that's kind of what you want. Men, let's wrap this up. 2 videos over 2 weeks, all having to do, well, the first one more had to do with building a test apparatus than having to do with wire. But this has gone on far longer than I thought it was going to. Bottom line gets to be this. Anything that was crimped with an automotive crimper failed the tensile strength requirement for the mil spec 6 out of 9 times. The automotive type crimper only succeeded in meeting the spec 3 times out of 9 tries. In the junk harness that I had laying around and in the samples that I tested. So it failed miserably. The goal was 41 pounds. It had to make 41 pounds before the crimp failed. Whereas the aircraft grade crimper passed, excuse me, ay, ay, ay. Whereas the aircraft grade crimper, even when crimping on the automotive type splices, managed to produce a crimp that made the spec every time I tried here, 100% of the time. So, the big thing again with using quality materials is consistency. The cheapo, squeezy player kind of crimp on things, how strong you feeling today. The materials those automotive ones are made out of, they're inconsistent. The thickness of the copper in the barrel probably has to do with it. The thickness of the insulation probably has to do with it. Has to do with how much force the crimper is able to exert on the crimp itself. But anyway, that's it for this little experiment. Hope you learned a little bit. I thank you all for watching. Thank you to my Patreons. Thank you to my other supporters. Get yourself a coffee cup. Get yourself a new sticker. Join me on Patreon. I'm still trying to give away the hardtail of this thing sitting behind me over here. If any of you patrons want it, just let me know, and it's yours, except for shipping. You got to pay for shipping, but free hardtail, pass it on. Anyway, I am out of here. See you all next time. Bye.